we're gonna continue on with 2.4. Okay, so when to use the opposite sign for a zero, I kind of wanted to throw this in there really quick as because kids tend to mix this up. So if we have a factor, so like this one, if it's in factored form, if we have x minus 2, x plus 3, x plus 4 is equal to 0. Here, when it's in factored form, our zeros are, this is where we take the opposite sign. So this we set equal to 0, this we set equal to 0, this we set equal to 0. So our zeros would be a positive 2, a negative 3, and a negative 4. Okay? Here, if it says your zeros are 4, 1/2, and negative 3, then your zeros are 4, 1/2, and negative 3. Okay? You do not have to put those as a negative. However, if we need to put this in factored form, we would say x minus 4, okay, x minus 1/2, which we need to do something more with that, and then the x plus 3, okay, and then if we have our, this one is good, if we have our 1/2, we're going to take that denominator and cite it out front, so then this would be x minus 4, and then 2x minus 1, and then x plus 3. That would be your factored form of your zeros. And then here, if we have a graph, our zeros are negative 4, negative 3, 2, which is actually the graph of this one. Then your zeros are still negative 4, negative 3, and positive 2. Okay, so make sure if it's in factored form, it's always opposite. And so you should be able to seemingly go back and forth between factored form and just listing out your zeros. Okay, and so let's get started on the second half of 2.4, and then this is the remainder theorem. And so if you have a zero, if you to figure out if a zero is actually a number, if a zero is a function, we can plug it in, and if we get 0 as our answer, then it is a function, or if it is a zero. But if it doesn't, then we can't. Okay, it's kind of like if we divide. Okay, if we divide by that factor, if we get a 0 out, then it's a factor. So what you do is you always do the opposites, because these are your factored form. So if f of x is divided by x minus k, then the remainder is r equals f of k. Okay, so we can find our remainder by plugging in, and it's always the opposite. So we can figure out what our remainder is without actually having to divide. Okay, and so it doesn't tell us what we're left with, but we can tell if it, you know, is a factor or not, and then if it's not, we can know what our remainder would be. So here, our k would be a positive 2. So we're going to plug in a positive 2. So we have 3 times 2 squared plus 7 times 2 minus 20. Okay, that would be 4. 4 times 3 is 12 plus 14 minus 20. That would be 26 minus 20. We get 6. Okay, so here, if we divided by, you know, your 2, then we get 3, 7, negative 20. We bring down our 3, that would be 6. We bring down our 13. Okay, that would be 26. We've got straight down 6. Oh, look, your remainder is 6. So that's all we're looking for. Okay, x plus 1. So our k is our negative 1. So we're going to plug that in. 3 times negative 1 squared plus 7 times negative 1 minus 20. Negative 1 squared is 1 times 3 is 3 minus 7 minus 20. 3 minus 7 is negative 4 minus 20. We get negative 24. So there's that remainder. Okay. Here, our k is negative 4, so we plug in a negative 4. So negative 4 squared plus 7 times negative 4 minus 20. So negative 4 squared is 16. 16 times 3 is 48. And then minus 28 minus 20. So 48 minus 28 is 20. Minus 20 is 0. Okay, so that tells me that negative 4, that, because we have a remainder of 0, that is a 0. So if we graph this right here on a graph, that would be an x-intercept. That would be a 0 of our function. Okay? And these two would not be. So in the same way, what we just did is applying this. If we divided by something, which again, what we just did, C, if we divided that by long division, the x minus 4, if we did all of our work, we'd get a remainder of 0, and then we would get 3x minus 5, okay? So x minus 4 is a factor, and so we know that one, our x, is equal to a negative 4. That's one solution. Okay, if we looked at our polynomial form to write our answer, it would be x plus 4 times 3x minus 5. Well, that would equal 0. So x plus 4 equals 0. We get a negative 4. And then we could even easily find out our other 0. So minus 5 equals 0. So that would be add 5. So 3x equals 5. Divide by 3x is equal to 5/3. Okay, and so that's our other 0. So whenever you divide by your dividend, if you get a remainder of 0, that tells you that what you divided by is a factor of that polynomial. Okay, and so if you graphed it, that's a 0. Okay, hopefully you can kind of see how this is all tying in. And since this was just a quadratic, that gave us both of our factors. Set them equal to 0, bam. We don't even have to do the graphing. We know that it's going to cross at negative 4 and 5/3. Okay, so let's look at, to figure out rational zeros. So you may have to graph these algebraically, and to figure out your rational zeros, you're gonna have to look at some possibles and then graph it and then kind of plug and chug to see what works to figure out your zeros, okay? To figure out zeros of quadratics, those are fairly easy, okay? Figure out cubics, as long as we find 1 0, then we get our quadratic and we can factor, but anything greater than 3, it gets a little trickier. So we can figure out possible zeros by looking at if x is equal to p over q, okay? So p is an inner factor of the constant coefficient a sub 0, okay? So this is p, and then q is the factors of your leading coefficient. So p over q. So if you do the factors of your constant over the factors of your leading coefficient. I hope that you coefficient leading, okay? And it's always plus or minus, okay? Because you can either have the positives or the negatives, okay? So let's look at, and so those are your possibles, and then you graph it, and then you look at what your possibles are, and you look at your graphing, and then you'll be able to look at what your rational zeros may be in order to kind of dwindle down your polynomial to where you can factor or use a quadratic, okay? So let's look at this. Remember so we are finding the rational zeros, okay? So this would be a non-repeating decimal, okay? A fraction, that's a ratio, that can be a stopped decimal or whole number. So we are going to find the rational zeros, and then we're going to completely factor, okay? And so we're finding the factors of all our zeros. So we need to figure out the potential zeros. So this would be your p, and this would be your q. So it's a fraction. So the possible factors of a -2 are a plus and a -1, and a plus or a -2. Factors of 3 are plus and -1, and a plus or -3. Okay, so now we break up and see what are the possibles. So we can do 1 over 1, so that'd be plus or -1. We could do 1 over 3, so plus or -1 over 3. Then we could do a plus or -2 over 1, so just 2, and then a plus or -2 over 3. So we just looked at like this one divided by this one divided by this one divided by this one divided by this. So we have four possible zeros. Okay, and so if we look at this, okay, your graph, well, we know if you look, it goes through these. Okay, so we know that those are possible zeros, okay, a -2. And we look at x equals 1. So those are whole numbers, but let's look at and figure out what that one is. And so you can kind of look at, okay, well, we know it's a negative. It could be either a -1/3 or a -2/3. But what I'm going to do is I'm going to divide by one of these factors that we know it is. Okay, we know it's I'm going to say a 1. We know it's a 1. So I'm going to synthetically divide by that 1. Okay, so we have our 3, we have our 4, we have our -5, and we have our -2. So we have our 3, 1 times 3 is 3, 4 times 3 is 7, 1 times 7 is 7, -5 plus 7 is 2, 1 times 2 is 2, -2 plus 2 is 0. Okay, that's a remainder, so this would be 3x squared plus 7x plus 2. Okay, and so now what we can do is we can do it again by this -2, but let's say I'm going to show you both ways that we can do it. Let's say that's going to be our new factor. So we know that we have, this would be an x minus 1, and then times a 3x squared plus 7x plus 2. Okay, well, we have this, so we have one factor. We could factor this out more, okay, by slide and divide. So that would be x squared plus 7x plus 6. Okay, the two factors that multiply to get 6 but add to get 7 are a 6 and a 1. Divide by 6. Okay, so we get x plus 1, and then we get x plus 1 over 6. Okay. Where did I mess up? Where did I mess up? Okay, now I'm gonna do it. I'm gonna back up. It's fine, it's fine. Stay with me. Let's divide by our -2 of this. We'll divide by a -2. We get a 3 and a 7 and a 2. Bring down our 3. -2 times 3 is a -6. That would be a 1. -2 times 1 is that, so it would be a 0. So we get 3x plus 1 equals 0. Okay, so we have our factors of x minus 1, which we did at the first. We have another factor of x plus 2. Okay, if you notice, these are opposite of there to our factored form. And then we have another factor of 3x plus 1. So we factored it completely. And so this factor would be a -1 over 3. I'm not sure where I mess up on my factoring of that, but it's fine, we're moving on. So here your zeros are x equals a +1, a -2, and a -1 over 3. So there's your zeros, and this is your factored form. Okay, so let's look at, this one is very simple. I'm not going to walk you through all of these steps because we know how to FOIL. But I'm going to get you started on it. So it says we have the following is function p defined by the polynomial with a degree of 3, so it'd be x cubed. So you're going to have 3 different polynomials, or 3 different factors. The zeros are -3, -1, and 4, and the leading coefficient is a -3. And so our zeros are x minus 3, so that would be x plus 3 as a factor. X minus 1, so x plus 1 is a factor, and then an x minus 4 as a factor with a leading coefficient of -3. Okay, and so that's p of x. And so you multiply. I would just multiply this out first, x times x, do this. Okay, so you get x cubed plus 3x plus 1, so it'd be 4x, and then plus 3 times by your x minus 4, and then you do that again. Don't forget your -3, so you do that, multiply it out, and then you multiply your -3, and then you'll get your polynomial. Okay? And then let's talk about upper and lower bound test for rational zeros. Okay, so whenever you synthetically divide, so if k is greater than 0, so these are your k's. If k is greater than 0, then every number in the last line for synthetic division is positive or a 0. And then if k is less than, so then our negative, every number in the last line is alternately negative and non-negative. And so k is a lower bound. So if the negative, you get positive, negative, positive, negative, then that's your lower bound, and then that would be your upper bound. Okay, so we just have to synthetically divide. So let's do our upper first. So we have 2, -7, 8, 14, and 8. Okay, so bring down our 2. 5 times 2 is 10. Negative, that would be 3. That would be 15. Oh, these are going to be bigger numbers than I would like to do quickly. That would be 23. 5 times 23. Hang on, I'm just going to get my calculator and cheat. Okay, we get 115. 14 plus 115 is 129. 129 times 5 is 645. 645 plus 8, this is huge, but it's okay. It's just asking if you have k is greater than 0. If all of these are positive, then this would be your maximum, okay? And so then you have, the minimum would be -2. So we're going to do this. We have 2, -7, -8, 14, and 8. We bring down our 2, so 2, that'd be -4, -11, 22, we get 14. times -2, we get -28, we get -14, we get +28, we get 36, okay? And so positive, negative, positive, negative, positive, okay? So then that means that is lower bound. So this is your upper bound, and this is your lower bound, okay? And if you graph it, you'll see those are your upper and lower zeros, okay? Or bound the maximums and your minimums, not zeros. They can't be maximum or your zeros because they didn't have a remainder of 0, okay? So those are just like your maximum and minimum values for your range, okay? So here, lastly, finding the real zeros of the polynomial function. And so here, you're gonna have to, I know it's easy to just plug it in the graph and use that, and that's perfectly fine, but you're gonna have to be able to factor rational or an irrational, emphasis on the irrational, and keep them in radicals. Okay, so if we have find all the zeros of 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8. Okay, so we can have at most 4, and if we graph it, we look, we have here, we have here, we have here, and we have here. So that's 4. Okay, so we know that +4 goes into that evenly. That's awesome. But we need to figure out what these are. Okay. And so if we do P over Q, so we do 8 over 2, so that would be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over plus or minus 1 and plus or minus 2. That would be 1 over 1, so plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 1, which we already have, okay, plus or minus 4, plus or minus 2, which we already have, plus or minus 8, and then plus or minus 4, which we already have, okay? So, and again, if we look, okay, and so we have our, so that tells us, if you look, that's why I was pausing, because I was like, hang on, that's not right. That is right. Okay, so we only have one fraction, which plus or minus 1/2, so it's either here or here. Well, obviously, spoiler alert, it's positive 1/2. So that means these two, because those are not whole numbers, those are going to be irrational. These are only how you find your rational. Okay, so we know, we can go ahead and know that that 0 is -1/2 because of that fraction. We know this 0 is 4. Okay, so we kind of don't really need those anymore. So we know that these two are going to be irrational zeros. So let's start at 4. Okay, because that's a whole number and that's beautiful. So let's start with, we have a 2, we have a -7, -8, we have a 14, and we have an 8. So let's just simplify this. So we bring down our 2, 4 times 2 is 8, -7 plus 8 is 1, 4 times 1 is 4, that would be -4. That would be -16. So that would be -2. 4 times -2 is -8. Okay, so there's your remainder. So there's 1 0. So now let's do it again. Okay, except now we're going to do -1/2. So bring it down, that's 2. So -1/2, so half of a 2 would be a -1. -1 plus 1 is a 0. Okay, so half of 0 obviously is 0. -4, bring that down. Okay, so half negative, so that would be a positive. Half of 4 is 2. Bring that down, that's a 0. Okay, there's your remainder. So now we have 2x squared plus 0 and then -4. Okay, so we have our 2 rationals. Now this tells me we're going to have 2 irrationals. Okay, so that equals 0. And so if we have to factor that out, we just need to solve for x. I'm going to kind of cheat and we're going to add 4 to both sides. Okay, so that would be, no, I'm not going to cheat. I'm going to show you the factoring way to do that because it's not always going to be this easy. Okay, so we got to factor this. So a 2 goes into both, so factor that out. So we have x squared minus 2 equals 0. Okay, so, and then let's factor this. So it's 2 is not a perfect square, but we can still take the square root to do our perfect square. So that would be your x plus the square root of 2 and x minus the square root of 2. Okay, and that equals 0. Okay, so our factors, if we factored all this, it would be x minus 4, x plus 1/2, or 2x plus 1. And then we got x, we have 2 out here, plus root 2, and then x minus root 2. Okay, so those would be the factored form, and then our zeros would be 4, negative 1/2, and then plus or minus root 2. Okay, so that's how you find your zeros. So these are two irrational zeros. Okay, and then that's it. 10 total questions. You have 2, like that last one that we went over. I expect answers. I don't expect you guys to be able to do that on your own. So we'll go over that for sure in class, hopefully. So let me know if you have any questions. Bye.